Hello and welcome to the week 3 videos in which we're going to be introducing conditional statements. Conditionals are going to allow us to select which program statements are executed dependent on data values. So if the data is in some set of range of values, or if some condition is true, we will be executing one branch of code, and if a different condition is true, we'll execute a different branch of code. But before we get to conditional statements, we need to introduce a new data type, the Boolean data type. So Booleans are very simple. They allow us to store two different values, and only two. Those values are true and false, and they're going to be used in a variety of different programming statements to allow us to select which parts of the program to run under certain conditions. So we get Boolean values either by testing relationships with the relational operators, including less than or equal to, greater than or equal to, and so on. You'll see a range of them here. We also get Boolean values by calling functions or methods that return Booleans. And again, we'll see some examples on the following slides. In particular, starts with or ends with in strings is a good example. We can also get Booleans by combining Booleans with logical operators, and, or not. So we'll see some of those in the coming slides, and it's a good idea for you to test examples of these in Wing IDE 101 as we go through. So obviously we can write simple expressions using Booleans. So we can say 10 is greater than 5. Obviously, hopefully, the result of that is going to be true because 10 is greater than 5. And of course, if we needed to, we could include these computations in an assignment statement. So is 10 less than 54? Well, the answer to that is true, and when we execute this assignment statement, we'll be calculating the expression which yields a result, in this case, true, and then we create a new dictionary entry for B that refers to that result. So we see no output here as usual, but we can inspect the value of B and we'll see that its value is indeed true. Is 56 greater than 54? Well, we expect the answer to that to be true also. 56 is greater than 54, but is 53 greater than 54? The answer obviously is false. So we've now seen the full set of values that we can have in a Boolean. It's either true or false. We can test the equality of things using the equals operator, and this is going to be an important one for us. So is 5 equal to 5? This is different to assignment. An assignment statement, like the one we've seen here, uses the equals operator. Equals with no space between them, that's a different operator, and it's one that tests equality. So is 5 equal to 5? Obviously we expect the answer to that to be true. Is 4 equal to 5? We expect the answer to that to be false. Okay. When comparing strings, mostly we get what you'd expect from dictionary order, just alphabetical ordered comparison. So is A, single character A, less than apple? We would expect that in a dictionary to be true, and it is true here. Is banana alphabetically less than apple? Well, we would expect that to be false, and that is indeed the case. Interestingly though, strings are case sensitive with the relation operators, and ABC is less than ABC because all of the uppercase characters are represented before the lowercase characters. So capital ABC is less than ABC, that's true. And Zach, which begins with a capital letter, is less than Alan, with the beginning with a lowercase letter, because all of the uppercase characters come before all of the lowercase characters. So capital Zach means that Zach is less than Alan. That's true. Midway through this slide, we can see something that's a meaningless error. If we try to say, is the int value 10 less than Fred, I've no idea what this comparison would mean. Int 10 less than a string Fred, it's a nonsensical comparison, and thankfully Python tells us that. It's got a nice little syntax error here for us, saying that less than is not supported between instances of int and string. So it's telling us we can't compare using less than an int and a string value. Other operators that we have accessible to us is red, in, Fred. Well, that seems reasonable. Red, R-E-D, the character sequence or string red is contained within Fred, so we'd expect that to be true. Is X in Fred? Well, obviously the character sequence X is not in Fred, so we'd expect that to be false, and it is. There are other operators. You can see them here, and you'll be working with them in lab, so do take time to experiment with that. The last example I want to give you, though, is with a method invocation. So starts with is a method defined for strings. I'm applying it to the string gonk, and I'm saying, does the string gonk start with the string go? And the answer to that is true. And we could ask the question, does gonk end with, let's say, capital NK? The answer to that is false, because uppercase characters are different to lowercase characters. But does it end with lowercase nk? The answer to that is true. Okay. So that's just a quick run through some examples of working with Booleans to return true or false values. Earlier we talked about operator precedence. So in expressions we can know which operators are applied first. Operators with higher precedence are applied before operators with lower precedence. And we've already said that exponentiation has the highest precedence, then multiplication, division, and modulo division all equal rank with the next level of precedence. Plus and minus have a lower level of precedence. Shift and bitwise operations, which won't be covered in COSC 121, come next. Then all of the relational operators have the same precedence, so that's less than or equal to, greater than, and so on. And then not comes next, and is applied after that, and or is applied last. Okay, so those are the rules associated with which operators are applied in which order in an expression that contains multiple operators. Python does have a nice shortcut that's handy for testing certain mathematical relationships, and it's called chaining of relational operators. So if we want to do something like determine whether I, an int value I, is in the range inclusive from low to high, in most computer languages we would have to write a more complicated expression like this. And you can write this also in Python. This is perfectly legal Python. So is I greater than or equal to low, and I is less than or equal to high. If both of those are true, then I is within the range we're trying to test. But Python allows a shorthand that looks like this. Low is less than or equal to I, less than or equal to high. So we negate the need to have this AND operation, or at least explicitly type the AND operation. So this is a nice mathematical representation, and it's perfectly legal in Python. But it's legal in Python to do things that are outside the normal mathematical representation of these ranges. Like we can have this chaining of relational operators is perfectly valid, but it results in strange outcomes. So let's just show you that briefly. The details of this aren't too important, so I'm just going to do it quickly. But if you're curious, you might want to do some testing with this. So, is 5 less than 10 equal to false? That evaluates to false. But is 5 less than 10 equal to true? Well, that also strangely evaluates to false. So what's going on here? Well, both of these expressions are shorthands for 5 is less than 10 and 10 is equal to false in the first case or true in the second case. So there are abbreviations for a combination that includes the AND operator, 5 less than 10, and 10 equals to false. But here we're doing an equality comparison between an int value and a Boolean value, which is kind of strange. And in Python, objects of different types, like int and bool, usually test unequal. But this is a feature of the language that hopefully you won't use. It's confusing, so only use this feature of chaining relational operators, where you're testing the range of values in the normal mathematical way. Boolean operators can also be used with non-bools, and this is another fact that we wish the language didn't. The language is less clean, more confusing because of it. So basically, only use Boolean operators with Boolean values, and avoid treating any other type of value as though it is Boolean directly. You can read the details of that on this slide, but it's an easy point of confusion and it's an easy way to write bad computer programs. So stay away from that feature. Use Boolean operators only on Boolean values. Okay, that's it for the introduction to Booleans. Next time we'll introduce the if statement. Thanks.